This is the Chapter 12 Practice Assessment. For the test, you will receive formulas needed for this particular assessment. In problem number 1, it says find the next 4 terms in the arithmetic sequence 7, 13, 19. First of all, it tells you it's arithmetic, so you know that it either goes up or down by the same amount. If you're not sure what value it goes up or down by, you can find the common difference by taking the second term and subtracting the first term. So we know that it goes up by 6 each time. So in order to find the next 4 terms, you're just going to add 6 to each consecutive term. So 19 plus 6 is 25, plus 6 is 31, plus 6 is 37, plus 6 is 43. So that's the next 4 terms in the sequence. In problem 2, we want to find the common difference D for a sequence with a sub 1 is negative 14 and a sub 11 is 266. Remember that this means the first term, and this is the 11th term. So we're going to use the formula a sub n is equal to a sub 1 plus n minus 1 times d. I know everything to plug into this formula except for d. A sub n is going to be the furthest term, so 266 is the 11th term, so it's going to go in for a sub n. The first term is negative 14, and n is 11 because the number over here is the 11th term. Remember, this is just an algebra problem. These are not like terms and cannot be combined. So first I would add 14 to the other side. So I would get 280 is equal to 10d. And then I would divide by 10 and find out that the common difference is 28. In other words, if I start at negative 14 and I keep adding 28, when I get to the 11th term, it'll be 266. The arithmetic means are just the numbers between 2 non-consecutive terms in a sequence. So in number 3, where it says write a sequence that has 2 arithmetic means between 16 and 64, I would start the problem off by writing this. So those 2 blanks in the middle are the 2 numbers I need to find in a minute. Well, in order to find those numbers, it would be really helpful if I knew the common difference. So we're going to go use this formula again. And the only thing I don't know is D. So a sub n is going to be the last term, which happens to be the 4th term because I know how many terms are in this sequence. The first term is 16. N is 4 because there are 4 terms. And I don't know D. So I'm going to do this similar to the way I did the previous problem. You cannot combine those. So first subtract 16. And you'll get 48 is equal to 3D. Then divide by 3, and you'll find out that the common difference is 16. Well, now that I know the common difference is 16, now I can find the other 2 numbers. So plus 16 is going to be 32, and plus 16 is going to be 48. And if you add 16 again, you should get 64. We had 2 formulas for finding the sum of a bunch of terms in an arithmetic sequence. One of the formulas for finding the sum was n over 2, where n is how many terms you're adding, times the first term plus the last term. But we don't always know the last term. So if I don't know the last term, the formula is n over 2, 2 times a sub 1 plus n minus 1d. So in this particular problem, I know the first term and the last term. So I'm ready to plug into the formula for the sum. So the sum is 11 over 2, because n is 11, 2 plus 52. 2 plus 52 is 54. 11 divided by 2 is 5.5. And 5.5 times 54 is 297. And that is the sum of the first 11 terms. Now let's talk about geometric sequences. Geometric sequences were the ones where you would multiply each previous term by a number to get the next term. The common ratio is really easy to find. You do the second term divided by the first term. So in problem 5, we want to determine the common ratio and find the next 3 terms in the geometric sequence 8, 12, 18. So R is 12 over 8, which is going to be 1.5. If you want to leave it as a fraction 3/2, that's fine, but I would say it's probably easiest to leave it as a decimal. And then we're going to multiply each consecutive term by 1.5. So starting with 18, 18 times 1.5 is 27, times 1.5 is 40.5, times 1.5 is 60.75. In problem 6, what if I know the common ratio and the fifth term is 144? What's the first term? The formula for the nth term of a geometric sequence was a sub n is equal to a sub 1 times r to the n minus 1. So a sub n is going to be 144, and n is going to be 5, because 144 is the fifth term. I don't know a sub 1, but I know the common ratio is -3. Notice that I put the common ratio in parentheses. If you don't do that, you might get the wrong sign in front of the number. So I always recommend when you plug something into a formula, put it in parentheses. So I told you to first subtract these before you plug it into your calculator. Then raise -3 to the 4th power. You will get positive 81. If you don't put the -3 in parentheses, you'll get -81 and you'll get the wrong answer. Then you divide both sides by 81, and you'll get a decimal. Just hit math enter enter, and it'll tell you that the answer is 16 over 9. And that's at least an exact answer. If the final answer at an end of a problem is a decimal, try hitting math enter enter and give me that answer. We're going to use this same formula from problem 6 and problem 7 in order to find the geometric means between 5 and 40. The geometric means work similarly to the arithmetic means. If there are 2 of them, that means there are 4 terms in the sequence and 2 numbers that I don't know yet between 5 and 40. In order to find those blanks, I really need to know what the common ratio is. So I must know everything in this formula except for R. I know the last term, and I even know it's the 4th term in the sequence. I know the first term is 5. All right, so first I'm going to divide by 5. The reason we're dividing and not subtracting is because that 5 is being multiplied by the r. So you have to divide, and you get 8 is equal to r to the 3rd. And then you get rid of the 3rd power by cube rooting both sides. Remember, the cube root function is under the math menu on your calculator. And you find out that r is 2. Now we know that the common ratio is 2. That's the number we're going to multiply by. So multiply by 2, you get 10. Multiply by 2, you get 20. And if you multiply by 2 again, you're going to get 40. The formula for the sum of a finite geometric sequence was a sub 1 r to the n minus 1 over r minus 1. So you need to know the first term, the common ratio, and you need to know how many terms you're adding. Well, I know the first term is 12. The common ratio is going to be the second term divided by the first term, which is 0.25. And n is 8 because I'm adding 8 terms. So in the parentheses is going to be 0.25 to the 8th power minus 1 over 0.25 minus 1. The way that I put this in my calculator is I put this in first in parentheses, and then I divide by this. And then I multiply that answer by 12. So, or you could plug it in your calculator like this. 12 parentheses, 0.25 to the 8th minus 1, close, divide by, parentheses, 0.25 minus 1. And the answer you get is 15.9997556. Some people were asking if they could round it to 16. Well, it's not quite 16, but if you hit math enter, you'll find out that the fraction is 65,535 over 4096. It's not pretty, but it's exact. In section 12.3, we talked about something called a limit. It's an introduction to calculus. And it turned out that limits, as our variable approached infinity, were the same thing as finding horizontal asymptotes when we talked about rational expressions. So we've done this before. There were 3 rules for how you determine what the limit is. The rules were, if the exponent of the variable in the numerator is the same as the highest exponent of the variable in the denominator, then the limit is the ratio of the coefficients in front of those terms. So b has a limit of -1/2. If the biggest exponent of the variable was in the denominator, then the limit was 0. But if you had a limit of an expression and the biggest exponent of the variable is in the numerator, then we said that the limit did not exist, or there's no limit. Number 10, it says find the sum, if it exists, of the infinite series 8 plus 4 plus 2 plus ... The only type of infinite series that you can find the sum of is an infinite geometric series. It cannot be an infinite arithmetic series. If this is arithmetic, you can't find the sum. And you check that right away. So like this goes down 4, and then if you subtract 4 again, you wouldn't be at 2. So it's not arithmetic. So it's probably geometric, as long as 4 over 8 is the same as 2 over 4. So the second term divided by the first term has to be the same fraction as the third term divided by the second, which it is. It's 1/2. All right, so the formula for finding the sum of an infinite geometric series is the first term divided by 1 minus the common ratio. So the first term is 8, and the common ratio is 0.5, and as long as you put that in parentheses, you'll find out that the sum is 16. For number 11, we gave you a way of doing summations in your calculator. If you have the math 0 function, if you press the math button, press 0, it might give you something that looks like this, and then you just fill in the blanks. The only thing you have to be careful about is the parentheses. You have to put this inside of the already given parentheses, which means you need a second set of parentheses. There's a long way of doing it. The long way of doing the problem was that you plug in every number from 2 to 6 and then add all those terms together. So if you start by plugging in 2, 2 squared is 4, 4 minus 1 is 3. I'm sorry, 4 minus 3 is 1, and 1 squared is 1. You plug in 3. 3 squared is 9. 9 minus 3 is 6. 6 squared is 36. If you plug in 4, let's see, I plugged in 2, 3, and then the next I will plug in 4. 4 squared is 16. 16 minus 3 is 13. 13 squared is 169. Then I got to plug in 5. 5 squared is 25. 25 minus 3 is 22. And 22 squared is 484. And then you plug in 6. 6 squared is 36. 36 minus 3 is 33. 33 squared is 1089. And then you add those 5 numbers together, and you end up with 1,779. Now, you didn't have to do it this way. You could have plugged this into Math 0 if you have a calculator with a new operating system, which is great for problems where you know the starting and ending value. But in problem B, the ending value is infinity. And infinity is not something that I can put in the calculator. So how am I going to find its sum? Well, let's look at this the long way first. I could find the first couple of terms in the sequence. 6 times 1/3 to the first power is going to be 2. 6 times 1/3 to the second power is 2/3. 6 times 1/3 to the third power is going to be 2/9. 6 times 1/3 to the fourth power is going to be 2/27. And I'm not going to keep going, but if you notice, the fractions keep getting a bigger denominator, and we know as the denominator in a fraction gets larger, the decimal version of the fraction becomes smaller. So what's going to end up happening is eventually the decimals will be like 0.000000000 something, and those numbers are essentially 0, so they become negligible after a while. And then this is a geometric sequence, because if you do the second term divided by the first term, 2/3 divided by 2 is 1/3. Or if you do the third term divided by the second term, 2/9 divided by 2/3 is 1/3. Hey, look, the 1/3's in the parentheses. And the first term is 2. So this is an infinite geometric sequence, like the previous problem. So I can find the sum by doing the first term divided by 1 minus the common ratio. I would put this in parentheses. I would not change 1/3 to a decimal because it's a repeating decimal. So I would just type in 2 divided by parentheses 1 minus 1/3, and it'll tell me the answer is 3. Number 12, expand using the binomial theorem. So if I give you on the board the first 4 rows, which is really 5 rows, of Pascal's triangle, you should be able to find row 6 by using the pattern we talked about. Remember that you're adding the 2 terms and the outside numbers are always 1. So here is going to be 1, 5, 10, 10, 5, 1. That's row 5. And now row 6 is going to be 1, 6, 15, 20, 15, 6, 1. There are going to be 7 terms in that expansion because the number of terms is always 1 more than the power you're raising it to. Now, if you can't remember this, the other way you can find the coefficients is you can do combinations. So the first combination would be C60, and that'll give you 1. The next one will be C61, and that'll give you 6. And then C62, that's going to give you 15. That's another way of determining the coefficients. But I would do it from Pascal's triangle. All right, so the first term in the expansion is going to be 1x to the 6th. The next one's going to be 6x to the 5th. Oops, let's put that parentheses in the right place. -2. Plus 15x to the 4th, -2 squared. Remember, in the binomial expansion, the first term starts with the largest exponent and each consecutive term goes down by 1. The second term, which you need to be careful, it's -2. Doesn't appear in the first term, but after that, each consecutive term goes up by 1 exponent. All right, so now I'm at plus 20x to the third, -2 to the third, plus 15x squared, -2 to the fourth, plus 6x, -2 to the fifth, plus 1, -2 to the sixth. Remember, in each term, the exponents should always add up to 6 before you've done your simplifying. So I haven't even done the simplifying yet. This is just setting up the problem. So the first term is just 1x to the sixth. But the next term is going to be 6 times -2x to the fifth, which is -12. The next term is going to be 15 times -2 squared. That's 15 times 4, which is positive 60x to the fourth. The next term is going to be negative because it's going to be 20 times -8, which is -160x to the third. The next term is going to be positive. It's 15 times 16, because that's what -2 to the fourth is. So it's 240x squared. The next term is going to be negative, because it's going to be 6 times -2 to the fifth is -32. So it's going to be -192x. And the next term is going to be positive, and -2 to the sixth is 64. So that's the expansion of x minus 2 to the sixth power. Now I need to tack on an extra problem that's on the test, and we accidentally omitted from the review. The other thing we talked about, I'll call this extra, is if you have an expansion like 3x minus 4y to the 15th power, and I want to find the fifth term. Well, you don't want to expand Pascal's triangle to row 15 and then figure out what the fifth term is. So we need another way of doing it, and the way we do it is by a combination. To find the coefficient of the fifth term, the combination will be 15 comma something, and we'll find that something in a moment. And then you're going to do some combination of 3x and -4y with exponents. Here's how it works. The exponent in front of the second term is always 1 less than the term you're looking for. If you're looking for the fifth term, then this is 4. This one then has to be 11, because those two exponents have to add up to 15. The second exponent is also the number that goes in this combination. So now, the first thing I'm going to do is find out what combination 15/4 is. Remember, you plug it in the calculator by typing in 15 first, then math, PRB, number 3, and so this should pop up on your screen, and then you type in 4. And the coefficient of that particular term is 1,365. We're going to multiply that by 3x to the 11th. So I have to raise 3 to the 11th power, which I'm sure is going to be huge. It's going to be 177,147, and then it's x to the 11th. And then we're going to raise -4y to the fourth. Well, when you raise -4 to an even power, it's going to be positive. So it's going to be positive 256y to the fourth. Now I can multiply these numbers together. So 1365 times 177,000 for 147, and then times 256 is so big on my calculator, I ended up being scientific notation. So I suspect the one on the test will not be scientific notation. So I got 6.19 times 10 to the 10th. Remember, E is not really E, it's times 10. X to the 11th, y to the fourth. Again, what you do is you first set up the problem, knowing that the two terms in the binomial expansion will have exponents. The exponent of the second one is always one less than the term you're looking for. And the two exponents have to add up to the whatever you're raising this to. And then the second exponent also is the second number in the combination. Don't forget, if you have any additional questions before the test, please feel free to email me.